9-3 Properties of Logs. So here are the 5 basic properties of logs. I'm going to go through them just kind of really quickly with you, but I also want you to study these and kind of check out the properties, and you're going to be referring back to this page later too to figure out which property are you going to use to either simplify logs or to solve equations involving logs. So the first one says if you're taking the log of a product, you can separate it into the sum of 2 logs. So if you have the log base b of m times n, you can split it up into 2 logs, the log base b of m plus the log base b of n. Number 2 says if you've got the quotient, you can split it up by subtracting. So you've got the log base b of m divided by n. You can actually rewrite that as the log base b of m minus the log base b of n. Number 3, this one comes in handy a lot. If you've got a power on either a variable or a number behind this log here, you can actually bring that power out in front. The log base b of m to the power of p is the same thing as p times the log base b of m. 4 and 5, these kind of make sense here if you think about these logs in exponential form. The log base b of b equals 1, so if your base and this part match, you're going to get 1 because b to the first power equals b. And number 5 also kind of makes sense here if you think about it in exponential form. The log base b of 1 always equals 0. So no matter what your base is, and that's because a base to the 0 power always equals 1. Okay, so how can we use these properties? Well, let's say that we're given 2 values here. The log base 3 of 2 is approximately 0.6309, and the log base 3 of 7 is approximately 1.7712. We can actually use these 2 facts alone and some of the properties that I just showed you to figure out what the log base 3 of 18 is, or the log base 3 of 14. So this first part, we kind of have to, they're kind of like little puzzles, we kind of have to be smart here about how we're going to use these properties. The one thing that might be helpful is if you rewrite these numbers as products. So instead of thinking it as the log base 3 of 18, I'm going to think of this as the log base 3 of 9 times 2. Now, how is that helpful? Well, 9 is the same as 3 squared, so I'm going to rewrite it one more time here. The log base 3 of 3 squared times 2. And now using the first property, I'm going to split these up into the sum of 2 logs. So I've got a product here of 3 squared times 2. Well, then I can split up my log as the log base 3 of 3 squared plus the log base 3 of 2. That's property number 1. Now I can use property number... which one is it here? Property number 3, and bring this 2 out in front, so I can say, well, this is just 2 times the log base 3 of 3 plus the log base 3 of 2. And then using property number 4, I know that the log base 3 of 3 is 1. So what I have here is 2 times 1 plus the log base 3 of 2 is up here. It's an approximation here, 0.6309. And now I can add these 2 together, and I get 2.6309. So what you need to do here is it's kind of like a puzzle. You're going to figure out how you can separate your logs into either the log of 2 or the log of 7, and then add or subtract the numbers, whatever you're doing here, to get your final answer. So let me show you this next one. We've got the log base 3 of 14. Well, 14 is 7 times 2, so that's going to come in handy here because I know the log base 3 of 2 and I know the log base 3 of 7. So let's rewrite it as a product. The log base 3 of 7 times 2. Well, now I can rewrite it as 2 logs. That would be the log base 3 of 7 plus the log base 3 of 2. If you've got a product here behind your log, you split it up using addition. The log of the first number plus the log of the second number. Okay, now the log base 3 of 7 is approximately 1.7712 plus the log base 3 is approximately 0.6309. Let's add these together, and I get 2.4021. Okay, now let me show you 2 more examples using the same 2 numbers. But this time, notice behind the logs we've got fractions or quotients here. So we're going to use property number 2. Instead of adding the 2 logs together, we're going to subtract the 2 logs. So we've got the log base 3 of 7 over 2. Well, using property number 2, I can rewrite this as the log base 3 of 7 minus the log base 3 of 2. It's the top one minus the bottom one. Okay, now the log base 3 of 7 we know is approximately 1.7712. We're going to subtract the log base 3 of 2, which is 0.6309, and subtracting these two numbers gives me 1.1403. Done. Okay, and then let me show you one more here. This one is not quite so obvious, but let's start by using property number 2 and rewrite this as the difference of two logs. So it's the log base 3, that base never changes, of 2, minus the log base 3 of 3, using property number 2. Now, we know the log base 3 of 2 is 0.6309, and the log base 3 of 3 is 1. Anytime your base matches what you're taking the log of, you're going to get 1. So 0.6309 minus 1 gives us 0.3691. And that's how you're going to solve those. The next few examples have to do with solving equations, and we're going to use the properties that I gave you on the very first slide. We're going to use the properties kind of backwards this time, though. Notice how the left side of this equation has a difference of two logs. We're going to try to combine these together into one log so that I can solve the equation. What you need to have in order to solve these equations is you need to have like bases, and we have that. They're all log base 5s. Okay, so that's good, but we can't just cancel out these logs. I need to combine the left side first. So we need to start here and simplify these two logs. Simplify. Okay, so which properties can I use? Well, notice this one has a 3 out in front. So I'm going to start by using property number 3. Please refer to that. But we're using it in reverse order. This 3 out in front can actually go back here onto the power on x. So this first log I'm going to rewrite as the log base 5 of x cubed by property number 3. Okay, so that's step number 1. Now notice I've got a subtraction sign in between these two logs, so that must mean that I'm taking the quotient of the log of a quotient. So it's log base 5 of x cubed over 4 equals the log base 5 of 16. So if you've got like bases here and you see a subtraction in between the two logs, you can simplify it into one log using division. Okay, that's property number 2, but in reverse order. Instead of splitting it up, I'm now putting it back together. Okay, now finally we're at the point where we can cancel out the logs. Because I've got the log base 5 on each side now, we can drop the logs and solve this equation. X cubed over 4 equals 16. Well, we're going to multiply both sides by 4. Multiplying by 4 cancels out the dividing by 4. Then you have x to the third power equals 64. And how do we cancel out a cube root? Or a power of 3. I'm sorry. How do we cancel out a power of 3? We take the cube root of each side. Okay, so x equals 4. The cube root of 64 is 4. Okay, here's letter B. Okay, there we go. Notice this time I've got 2 log base 4s on the left, but I've just got a number 2 on this side. That's okay, we can still solve this one, but again, you need to simplify. So we're going to start here with simplifying these two logs. There's a plus sign in between, so I'm going to use property number 1 and multiply the parts. So it's log base 4 of x times x minus 6. If there's a plus sign in between them, then you got to multiply. Okay, and that equals 2. Now, the easiest way to solve this is change it from log form into exponential form. So remember, when you convert into exponential form, it just kind of swings in a circle. 4 is your base, 2 is your power, and it should equal this thing right here. So I'm going to take 4 to the power of 2, set it equal to x times x minus 6. Now we got to work on solving this equation. So 4 squared is 16. Let's distribute the x. We get x squared minus 6x. And I think I'll set this equal to 0 here. So my trinomial quadratic equation is x squared minus 6x minus 16 equals 0. So I subtracted 16 on both sides, and then I also switched my equation. Now this one actually factors. I can think of two numbers here that multiply to negative 16 and add up to negative 6. That would be negative 8 and 2. So my two factors are x minus 8 and x plus 2. Each factor is set equal to 0. If x minus 8 equals 0, then x would equal 8. If x plus 2 would equal 0, then x would equal negative 2. Now, you should check your solutions here. If I plug in 8, I'm going to take the log of 8 and the log of 2. That's good. Remember, you can only take logs of positive numbers, so 8 works. And now let's check negative 2. If I plug in negative 2, this first log already is undefined. You can't take the log of a negative number, so the log base 4 of negative 2 is undefined. The second one's also undefined because if you plug in negative 2, you're going to be taking the log base 4 of negative 8. Those are undefined logs, and so we don't want to use negative 2 as a solution. So x equals 8 is the only solution here, and you could definitely check it if you wanted to. Okay, last one here. The log base 2 of 12b minus 21 minus the log base 2 of b squared minus 3 equals 2. This is a tough one, so I'm going to work through it with you, of course. So on the left side of my equation, I've got 2 logs with the same base. We need to simplify that, in this case, using property number 2. It's a subtraction, so that means when I set this up, when I combine them, I'm going to write a quotient. It's the log base 2 of 12b minus 21 over b squared minus 3. Because there's a subtraction sign between them, I know I need to write a fraction. Okay, and that equals 2. Now again, there's no logs on the right side here, so I'm going to change this now into exponential form. It's base 2 to the second power equals this whole thing in parentheses. So 2 squared equals 12b minus 21 over b squared minus 3. Now 2 squared is just 4. So let me rewrite the equation. And I'm looking for b. First thing I'm going to do here is get rid of my fraction. So I'm going to multiply both sides by the denominator, b squared minus 3. And over here, b squared minus 3. Doing that cancels out your fraction, and now you can rewrite your equation as, oh, over here I guess I'll distribute, and maybe I'll write it up to the right here so I have room. We're going to multiply by 4 now on this one, so we have a 4b squared minus 12 on the left equals 12b minus 21 on the right side of our equation. We're going to end up solving a quadratic equation again here, so what you need to do is set it equal to 0. That will always help you because then at that point you can factor it, you can use quadratic formula, or you can graph it. So I've got a 4b squared. I'm going to subtract 12b, so minus 12b, and then I'm going to add 21 to this negative 12. And doing that gives me plus 9 equals 0. So I subtracted 12b and I added 21. Okay, so I get this quadratic equation. It does factor. It factors into 2b minus 3 times 2b minus 3. 2b times 2b gives you 4b squared. 2b times negative 3 gives you the negative 6b. Another negative 6b makes negative 12b, and then negative 3 times negative 3 is positive 9. Okay, so I've got just one factor here, 2b minus 3, set it equal to 0, and b equals positive 3 over 2. Okay, I've got one more for you to try. Solve this log equation. Think about some of the properties that I gave you on that very first slide. You need to simplify each side first, combine them into log base 7s, and then you can cancel out the log on each side and find